Hello students, your teacher here, Mr. Sarasinski, with another episode of Algebra 1 review packet number 5, second to last review packet, woot. So we're almost there, guys, so keep working hard. This review packet is all about exponents and exponent rules and then polynomials. And so let's jump right in, mostly polynomials. Product rule. This is when you're multiplying variables with exponents, you add the exponents, okay? Quotient rule, when you're dividing variables with exponents, you subtract the exponents, okay? It's the opposite of the product rule, so that should help you remember it. If you're multiplying, you add. If you're dividing, you subtract. Power rule is when you're raising an exponent, a variable with an exponent to a power, you multiply the exponents. And to get rid of a negative exponent, remember anything can be written over 1, you just move the negative exponent to the denominator. So that is how you get rid of a negative exponent. All right, so let's jump in. Number 1, this is the product rule. And product rule, you multiply the coefficients just like normal. 7 times 8 is 56. M to the first times M to the second is M to the third and V to the fifth. That just gets multiplied, but it didn't have anything to combine with. All right. Number 2, power rule. So this is like 4 to the third power, x to the 3 times 3, which is 9, and y to the 5 times 3, which is y to the 15th. And 4 to the third power is 64. So that's 64, x to the 9th, y to the 15th. Number 3 is the quotient rule. 35 divided by 5 is 7. K to the 10th divided by k to the 2nd, subtract, and you get k to the 8th. Number 4, power rule, then product rule, and power rule takes precedence. That is the one you need to simplify first. Negative 2 squared is positive 4. A to the 6th times 2 is a to the 12th. B to the first times 2 is b squared. And c to the third times 2 is c to the 6th. And we're multiplying that by negative 5ab squared. 4 times negative 5 is negative 20. A to the 12th times a to the first is a to the 13th. You add. B squared times b squared is b to the 4th. And c, poor c, didn't have anything to combine with. So we just add it in there at the end. Number 5, quotient rule. R to the 16th divided by r to the 4th. Subtract 4 from 16, that's 12. S to the 2nd divided by s to the 2nd is s to the 0. And anything raised to the 0 with power is 1. It just goes away. Cancels out. T to the 3rd divided by t to the 8th is 3 minus 8, which is negative 5. Okay, so we can write this over 1, and it doesn't change it. And then to get rid of t to the negative 5th, we're going to move it to the denominator. So the answer is r to the 12th over t to the positive 5th. Okay. Number 6, power rule, product rule in the denominator, quotient rule. All right, so one step at a time. Negative 3 squared is positive 9. K to the 6th times 2 is k to the 12th. Divided by 5 times 3, which is 15. K to the 3rd times k to the 3rd is k to the 6th. Add the exponents. Now this simplifies. 9/15 simplifies to 3/5. K to the 12th divided by k to the 6th is 12 minus 6. It's positive 6. That is our answer. All right, 7. Everything is taking the power rule here. So this is like 4 squared, which is 16. M to the 4th times 2, which is m to the 8th. N to the 2nd times 2, which is n to the 4th. Over 6 squared, which is 36. M to the 5th times 2, which is m to the 10th. And n to the 1st times 2, which is n squared. So now we have to take the quotient rule. And I'm just going to bring this down and wrap it around this way. So 16 divided by 36 will simplify. Let's see, 8 divided by 18, 4 divided by 9. Okay, just dividing by 2 and to get it to simplest form. M to the 8th divided by m to the 10th, that's 8 minus 10, which is m to the negative 2. Now, I could have written that in the denominator and just gotten rid of the negative, but I wanted you to see it first. N to the 4th divided by n to the 2nd is n to the 2nd. So the only thing I have to complete now is getting that m in the denominator so that we have a positive exponent. You should never leave a negative exponent. Okay, if you have a negative exponent, it's not simplified. So this is 4 n to the 2nd over 9 m to the 2nd. Okay. Number 8, we got power rule, product rule, and then combining like terms. X to the 1st times 2 is x squared. Y to the 3rd times 2 is y to the 6th. Now I need to take the product rule, and negative 2 times 1 is negative 2. X squared, we write our variables in alphabetical order. Y to the 4th times y to the 6th, add, you get y to the 10th. And then we need to see if that will combine with negative 13x squared y to the 10th. And yes, it will, because they have the same variables with the same exponents. So negative 2 minus 13 is negative 15x squared y to the 10th. Okay. Number 9, quotient rule, and then negative exponent rule maybe. So negative 5 divided by 20, that's negative 1/4. P to the 2nd divided by p to the 1st, negative 1, that's 2 minus negative 1. And anytime you have, okay, so this is like 2 minus negative 1, that's like plus a positive. So this is going to be 3. So this is p to the 3rd. And then 8 minus 2 is q to the 6th. And that's your answer. Easy peasy. All right, now sometimes you'll see that they won't write the negative 1 there. It'll just be negative p to the 3rd, q to the 6th over 4. That's also a possible answer. If there's, and it's only when there's a negative 1, okay? If it's a negative 1, you technically don't have to write it. Just like if it's positive 1, you technically don't have to write it. You can just put that negative sign, or if it's positive, no sign at all. All right. Number 10, power rule in the denominator. So in the numerator, we still have a to the 12th, b to the negative 3rd. But in the denominator, okay, we have a to the negative 4, b to the negative 4. Okay. 12 divided by a to the 12th divided by a to the negative 4th. That's 12 minus negative 4. That's going to be a to the 16th. And b to the negative 3rd minus negative 4. Remember, that's like negative 3 minus negative 4, which changes to plus a positive. So that's going to be b to the 1st, or just b. And that's simplified. That was awesome and easy. Number 11, we've got power rule, and then product rule. 2 to the negative 2 power is 1 over 4. And then v to the negative 2 power, so that's going to be v squared in the denominator, times 6 to the 3rd power, which is 6 times 6 is 36, times 6 is 216. V to the negative 7 times 3 is v to the negative 21. So this is like v to the 216 over v to the 21st power. Now, if we multiply, that's going to be 216 over 4. V to the 2nd times v to the 21st is v to the 23rd. And 216 divided by 4 will actually simplify. Let me see. 216 divided by 4 is 54. 54 over v to the 23rd. Okay. All right, and number 12, everything's getting the power rule. This is going to be c to the negative 28th, d to the 4th over 3 times 3 is 9, times 3 is 27, times 3 again is 81. C to the negative 2 times 4 is C to the negative 8. And D to the 5 times 4 is D to the 20th. Now, if we simplify that, so I'm going to bring this over here. Negative 28, so if we're dividing, we're still going to have 81 in the denominator. C to the negative 28 minus negative 8. So this is like negative 28 minus negative 8. That's going to be plus a positive 8. So we'll have C to the negative 20. And then D to the 4th minus 20. That's 4 minus 20. It's going to be D to the negative 16. And so both of those need to move to the denominator. So I have 1 over 81 C to the 20th D to the 16th. And that's it. Okay. All right, so that's exponent rules, all right? I know it's a lot, but, you know, just stick to the basics, remember the rules, and you'll know how to manipulate them when you see them. Take it one step at a time. Negative exponents move to the denominator to clear. All right. Topic 2, simplifying polynomials. So this is pretty basic, all right? If you're adding, you can just drop the parentheses and combine like terms. If you're subtracting, you need to distribute the negative, then drop the parentheses and combine like terms. So here we go. And I just realized I did all those exponent examples. I'm going to do 14, 16, and 18. You guys will do 13, 15, and 17. So 14, we are distributing the negative. So it's going to be negative x squared plus 4x plus 1. And then over here, we're just going to drop the parentheses and combine like terms. So 2x squared minus x squared, that's 1x squared, or just x squared. And I like to mark them out as I go. 3x plus 4x is 7x. And negative 2 plus 1 is negative 1. That is it. Number 16, we're adding. So just combine like terms. You don't even really have to drop the parentheses. M to the third plus 7m to the third is 8m to the third. Negative 3m squared plus m squared is negative 2m squared. Negative 6m plus m is negative 5m. And 6 plus 11 is 17. Easy. Okay. All right, number 18, we need to distribute 2 times. Okay. Once, because there's something in front of the first parentheses, and don't forget, anytime there's a negative sign in front of parentheses, it's like negative 1, and you have to distribute it because it's going to change the signs of everything in that parentheses. So this is negative 9p cubed plus 2p squared. And then in the first parentheses, I have 8p cubed plus 56p squared minus 16p. Okay, now combine like terms. 8p cubed minus 9p cubed is negative p cubed, or negative 1p cubed. 56p squared plus 2p squared is 58p squared. And then minus 16p, that's all we got left. And that's the answer. All right, next. 19. So in 19 through 24, we're multiplying binomials. And when we learned about multiplying binomials, we practiced the FOIL method, okay, FOIL, and it stands for first, outside, inside, and last. But what I really want you to think about is just distributing, right? So we're going to distribute this first number to everything in the second parentheses, and then we're going to distribute the second number to everything in the parentheses. And it's that simple, okay? It's really not any harder than that. So just remember parentheses, because when we get down here in 25 and 26, we don't have the option of foiling because we're multiplying by a 3 term, okay? So, just remember to distribute. All right, so I've circled the ones that I want you to do for homework in this section, 21, 23, 25, and 27. All right, so like I was saying, all we're doing is distributing here. X times x is x squared. X times 7 is 7x. Negative 9 times x is negative 9x. And negative 9 times 7 is negative 63. Now we can combine the two x terms. So x squared minus 2x minus 63 is your answer. That's simplified. That is a standard form trinomial. And the reason I know it's standard form is because it starts with the highest exponent and it goes in descending order. So x squared, x, and then no exponent, or no variable. Number 20. This is called a difference of squares. And you guys have seen these before. I wanted to draw your attention to the name. And as we start to multiply, you'll see what I'm talking about. W times W is W squared. W times negative 8 is negative 8W. 8 times W is positive 8W. And then 8 times negative 8 is negative 64. The two inside terms are what we combine, but they cancel out. And so all we're left with is a binomial. First term is squared, and it's a difference, okay, like it's subtraction. And both of these terms are square rootable. The square root of W squared is W, and the square root of 64 is 8. So when we were factoring these, we would do W plus 8, W minus 8, okay? Just going a little backwards right now. All right, so that's it. 22. Distribute. 2k times 3k is 6k squared. 2k times negative 4 is negative 8k. Negative 5 times 3k is negative 15k. And negative 5 times negative 4 is positive 20. Combine your two inside terms, so 6k squared minus 23k plus 20. All right, 24, expand. Okay, so we can expand this and rewrite it as 2y minus 1 times 2y minus 1, because anytime we square something, that's essentially all we're doing. We're just multiplying it by itself, and the exponent tells us how many times to do that. So 2y minus 1 times itself, so 2y times 2y, 4y squared. 2y times negative 1 is negative 2y. Negative 1 times 2y is negative 2y. And then negative 1 times negative 1 is positive 1. Combine the two inside terms. That's 4y squared minus 4y plus 1. All right, 26. This time we're multiplying a binomial and a trinomial. And this is why I was telling you just to distribute, okay? So the first term is going to multiply by everything in the trinomial. That's going to be 2c cubed minus 6c squared minus, 22c. And now 1 times c squared, that's c squared. 1 times negative 3c is negative 3c. And 1 times negative 11 is negative 11. Combine like terms. 2c third doesn't have anything to combine with. I'm going to rewrite that. Negative 6c squared plus c squared is going to be negative 5c squared. And negative 22c and negative 3c is negative 25c. And then bring down the negative 11. Okay. Number 28. So we're dividing a polynomial by a monomial. And so basically it's just like 3 separate division problems, right? It's like you're dividing this, then you're dividing this, and then you're dividing this. Okay, so that's how we're going to work it out. Negative 24 divided by negative 8 is positive 3. X to the 4th divided by x squared is the quotient rule. We subtract the exponents. That's x squared. Negative 8 divided by negative 8 is positive 1. X to the 3rd divided by x squared. 3 minus 2 is x to the 1st. And then 40 divided by negative 8 is negative 5. X squared divided by x squared, they just cancel out. So what we're left with is a trinomial in standard form, 3x squared plus 1x minus 5. All right, 29 and 30. I'm going to do these both with you. 29, we have to do some interpreting before we can set it up. And so the length of a rectangular classroom floor is 19 feet less than. That word less than is a backward word phrase. That's a backward word phrase. That means the way it's written is the opposite of how you're going to write it. So the length is 19 feet less than twice its width. So that's 2x minus 19. The width is just going to be x. And I knew that because they were describing the length in terms of the width. So since they're describing the length in terms of the width, then I know that the width is just x. Okay? It says write an expression to represent the area of the floor in simplest form. Well, area of a rectangle is pretty easy. It's length times width. So the area equals 2x minus 19 times x. Okay, so we just need to distribute. 2x times x is 2x squared. Negative 19 times x is negative 19x. So the area equals 2x squared minus 19x, and that's it. That's as simplified as we can make that. All right, number 30. Write an expression to represent the area of the shaded region below in simplest form. Well, if we find the area of this whole rectangle, and then we find the area of this smaller rectangle, and then subtract them, that will give us the area of this shaded region. Okay, so here we go. The area of the larger rectangle, length times width, or vice versa, it doesn't matter the order that you put them in. That's going to be 2x minus 3 times 4x plus 7. And then we need to subtract the area of the smaller rectangle. So that's going to be x times x minus 1. Okay, and I put them in brackets because we need to do one part at a time and then subtract, okay? So 2x times 4x is 8x squared. 2x times 7 is 14x. Negative 3 times 4x is negative 12x. And negative 3 times positive 7 is negative 21. Okay, so I can combine my inside terms and I get 8x squared plus 2x minus 21. I'm going to put that back in my bracket now. And I'm going to subtract whatever this equals. So x times x is x squared, and x times negative 1 is negative 1x. All right. Now, just like before when we had subtraction in between the parentheses, you have to distribute. So this is going to be negative x squared plus 1x. And then I'm just going to drop this bracket and bring everything down and start to combine like terms. All right, so 8x squared minus x squared is 7x squared. 2x plus 1x is 3x. And minus 21. There's the area of the shaded region represented by algebraic expression. All right, 31. You know, I haven't really seen, this is a curriculum that I purchased, and I haven't seen any problems like this. I'm not really sure why they chose to put one here at the very end in the review packet. But it says, write a polynomial to represent the following. And we have shapes here that represent variables, okay, and numbers. And so to simplify this, I'm going to write, this is going to be 2x squared, and then minus 3x minus 2. Put that in a bracket, and then we're subtracting whatever this equals, okay? So that's going to be x squared minus x plus 3. And I have to distribute the negative. This is going to be negative x squared plus x minus 3. And then I'm just going to drop the parentheses and start to combine like terms. 2x squared minus x squared is going to be x squared. Negative 3x plus x is negative 2x. And negative 2 minus 3 is negative 5. Okay. All right, moving on. Topic 3, simplifying radicals, square roots, and cube roots. List the first 15 perfect squares. So this is the first 15 numbers squared, okay? 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 196, 13 squared is, I just messed up. No big deal. 13 squared is 169. 14 squared is 196. They just transpose the numbers. So it's easy to remember. If you can remember, it's the same, just switched. And then 15 squared is 225. So when we were simplifying radicals, and I'll do 33 and 35. When we're simple, actually I'll do 34 and 35. Those seem to be the bigger numbers. So your homework is going to be 32 and 33. You're looking for the largest perfect square that is a factor of these numbers. Okay, so none of these are perfect squares. So we're trying to break them apart into 2 factors, and one of them has to be a perfect square, okay? So 448, I notice, actually I didn't notice, I just started dividing, right? I started up here at the top. 225 was more than half, so I knew that didn't go. 196 didn't go. 169 didn't go, and so I just going down the list. Some of these I didn't even have to try. I knew 100 wouldn't go in. 121 times 4 is 484. So some of these I didn't have to actually try on my calculator. Then I got to 64. So 448 can be broken apart into 2 factors. 64 times 7. So the square root of 64 times the square root of 7 is the same thing. These are equivalent, okay? What I've written here and the original radical. So the square root of 64, we can take that because that's 8. And then we still have 7 left behind. And that's how you simplify non-perfect square roots, okay? Non-perfect radicals. All right, so number 35 started at the top. And 196 goes into 392 two times. So the square root of 196 times the square root of 2. And the square root of 196, we know that to be 14. So 14 times the square root of 2. This and this are equivalent, okay? If you were to put them in your calculator, you would get the same value. All right, so list the first 10 perfect cubes. So this is like the first 10 numbers cubed. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343, 8 cubed is 512, 9 cubed is 729, and 10 cubed is 1,000. So we're going to do the same thing with these. I'm going to leave you 36 and 37 for your homework. I'm going to do 38 and 39. 38 and 39. So the square root of 108, I'm looking for which one of these cubes, or the cubed root of 108, which one of these cubes goes into that evenly. And it looks like the cubed root of 27 times the cubed root of 4. And 4 is the square root, but not a cubed root. So the cubed root of 27 is 3 times the cubed root of 4. And that's your answer. So we're doing the same thing as up above. We're just breaking it apart into their largest cubed root. So the largest cubed root that goes into 192 is 64. times the cubed root of 3, because 64 times 3 equals 192. And the cubed root of 64 is 4 times the cubed root of 3. And that's your answer. All right, so simplifying monomial square roots, a little bit different. The rule here is that if you have a variable raised to an odd power, okay, and you're taking the square root, you can split it apart into the square root times 1, right? The square root, so we just basically subtracted 1. So now we have m to the second times m to the first, and this is equivalent. But we can take the square root of m to the second. It's just m. So this simplifies to m times the square root of m to the first. All right, so we subtract 1 from the exponent. And then you can basically, I think what I'm trying to say, and I'm not doing a very good job, is that you can only take the square root of an even number. So if it was even, let's say we had the square root of m to the fourth, all you have to do is divide the exponent by 2. So that would be m squared. Okay. All right. So I don't feel like I'm doing a very good job explaining it. Maybe seeing it will help you. 24. So 24 is not a perfect square, but it can be broken apart into the square root of 4 times the square root of 6 and times the square root of x squared. All right, so these two we can actually take the square root of. The square root of 4 is 2. The square root of x squared is x, and then we have the square root of 6 left behind. Okay, so I've circled the ones that I want you to do, 42, 43, 45, and 47. I'm going to work out the rest. So number 41, we can break this apart into the square root of 81 times the square root of m to the fourth times the square root of m to the first. Since I noticed that this was an odd exponent, I rewrote it by taking 1 out and leaving it as m to the fourth times m to the first. Now these two I can take the square root of. The square root of 81 is 9. Square root of m to the fourth is m squared. And we have the square root of m left behind. 44, looking for the largest perfect square that will go into 320. Okay, and that is going to be 64 times 5. So this is like the square root of 64 times the square root of 5 times the square root of x to the 18th. I knew I didn't have to take x to the 18th apart because it was raised to an even power. So we can take the square root of these two. Square root of 64 is 8. The square root of x to the 18th is x to the 9th. And then we have the square root of 5 left behind. Number 46, the square root of 1/9 times the square root of x squared times the square root of y to the 10th. Actually, all three of these are square rootable. Square root of 1/9 is 1/3. The square root of x squared is x, and the square root of y to the 10th is y to the 5th. Last one, number 48. 147 can be broken up into factors of, actually, let's just do this. Let's just break it all apart here. I'll start out with this, times the square root of c to the 15th, times the square root of d to the 20th. D to the 20th, I don't have to do anything to. The square root of 147 can be broken apart into the square root of 49 times the square root of 3. And c to the 15th can be broken up into c to the 14th times c to the 1st. And then that's all times the square root of d to the 20th. 49, c to the 14th, and d to the 20th can all be square rooted. So that's 7, c to the 7th, d to the 10th. And then left over, we have the square root of 3c. Okay. All right, guys, that's it. I'm your teacher. This is the way.